have a lot of slides to go through, but I think it'll be a bit of a departure from a lot of what we get at SciPy. The technical detail is going to be very scant, so I think you should be able to just understand what I'm saying pretty well. But if you don't, just wave at me and I'll slow down and answer questions. This is, BCE also stands for Before Common Era, right? And so I'm pushing to get this long-tailed dinosaur as our sort of like data science from before time mascot. So another name for the BCE is yet another approach to making code installation and documentation easier, right? I mean, two of the big organizations here, Mthought and Continuum, both have very ambitious and good solutions to reducing complexity in setting up scientific code, but I'm going to talk about some other stuff that maybe you haven't been thinking about. I teach a lot of social science grad students who have no idea what a command line is. You know, it's just not part of typical sociology undergraduate training, right, to learn how to install scientific compute tools. So you'll get a little bit of my perspective from the social sciences. It's actually kind of three really short talks, and I will start with our motivation and the challenges we face. So this will be a little bit about who we are, the people we serve, and then I think critically, I don't know how many people here engage in sort of user-centered design process, but this is kind of the first question we're asking before we start implementing technical solutions. Just what do our users actually need and want? And then ultimately, what do we, the people building this tool, need and want from, you know, further down the stream? So who are we? This is a stock photo from Keynote, but it really represents my feeling about the team. We're coming from all over campus. I'm going to focus mostly on the D Lab, the Statistical Computing Facility, and the Berkeley Research Computing. So the D Lab, we are a startup organization organized outside of traditional departments, so we're not really integrated into any particular curriculum. People come from all over campus, and we can really assume essentially nothing apart from people kind of know how to use a computer, right? You can't assume that people have had any particular training, although sometimes people come in and they know, you know, some narrow thing very well, or even a broad set of things. We support computational social science. Those are in quotes because sometimes we get engineers come in. You know, we don't say like, well, you're not really a social science person. And computational also might not be what you think of as computational. It might be how do we organize a team of undergrads to work effectively on a large spreadsheet, right? Like just sort of applying systematic thinking. I've already mentioned computation is not generally taught. And the D Lab, we work on training tools and community to address this training need. The Statistical Computing Facility is more of a traditional established organization. It supports statistics, it's got an instructional lab, they support cloud resources. And then Berkeley Research Computing is a new organization as well, with a lot of senior people from campus IT. And they're trying initially to get a high-performance cluster going, but they're moving towards virtual workstations and cloud services and storage and consulting and probably more stuff. So it's a pretty broad consortium of people aimed at different communities across campus, right? So broadly speaking, we're targeting instruction, teachers and students, and researchers who are engaged in collaboration, and reproducibility and reusability and transparency are really important to us. In terms of instruction, we see more non-traditional students and courses. Like the D Lab is all non-traditional, basically. And people are seeing things for the first time a lot. They have a range of computing environments.
What does non-traditional mean, sir?
Oh, what is traditional?
What is non-traditional?
Oh, like for example, political scientists, you know, doing graph-based intelligent agent modeling would be non-traditional, as opposed to like from the STEM backgrounds. I think probably most people here are from the STEM background.
Why don't you ask?
How many people here are from the social sciences? How many people here are from a sort of hard science, engineering, mathematics background? Okay, thank you. I mean, that's probably much more compelling than me saying it, right? So we don't necessarily have a lot of experience with these people. And I'm gonna skip through, and basically I have the same story about research, right? So we're seeing more transdisciplinary collaboration, more open source tools, which is cool, right? But people are, again, seeing things for the first time. They have a range of computing environments. Right, so I want to make it easy for researchers to write clear instructions, make it easy to follow papers, and can we get researchers to learn new technology? Well, they already are, and they're probably busy, right? So the burden is kind of on the support structure to make these things easier to use, right? And if you want people to learn new technology, don't get professors to do it. That's. I also just want to highlight. I think this is an important issue for equity. For whatever reasons, SciPy is dominated by pretty narrow demographics, right? And you can look around the room and pick your demographic. The more barriers we can remove, the more we can get rid of those reasons, right? The more we can have a big tent and have really cool, exciting research that bridges, integrating from physical science to policy and wearable computing that helps you have a better life, stuff like that. Right, so we're not really doing anything hard for us, right? But on the flip side, this stuff is really challenging for a lot of our incoming users. Mostly we need more time, right? So can we make tools that make it easy for us to bring in collaborators who are working with us? Can we kind of like minimize how much we have to explain what we're doing? And can we just be lazy and not learn anything if we don't have to, right? Can we just do stuff? And in particular, we need to manage complex requirements, help people easily transition between laptops, workstations, the cloud, right, and keep administration as light and accessible as possible. Right now, there's probably 3 of us who will end up supporting, we don't quite know how many courses in the fall, and that's not any of our primary job, right? So we kind of we don't want to deal with it at all. We want to have something polished and just ship it out and it works. Right, so what's the tech available to make stuff like that? So there's this new thing called DevOps. You might have heard of it. You have a pile of crusty code that's hard to install. And how many people have a pile of crusty code that's hard to install? There we go. So not everybody, right? But like the other people in the room might want to use that stuff. But it's hard to document how to install it. And so the DevOps idea, it's this portmanteau of development and operation. It's like, well, you could develop scripts that install your tool set, right? And why would you not do that? Well, maybe that sounds hard, right? But I would counter, it's more fun than writing documentation. How many people like to write documentation? Yeah, so some people, I also actually like writing documentation, but I still think I enjoy writing code more. So, some inspiration for us initially came from this project called Jiffy Lab, which I think Preston, I saw him. I don't know if he's here. So Jiffy Lab is really cool. It uses Vagrant to automatically provision a virtual machine on VirtualBox, EC2, DigitalOcean, or Rackspace. The virtual machine uses Docker to virtualize isolated nested containers that run the IPython notebook and shell in a box, which are both accessible via web browsers. And processes inside the Docker containers are managed using Supervisor. So it's got like, you see, you're like, wow, look, you like organize all this tech and it's so cool. And like I could just download it and like type one command on the command line and like half an hour later, the computer did all this stuff and it just goes boom. And you have like a full virtualized server for like 20 people running on your laptop. Right? But the problem is, if you recall the kinds of people I'm working with, right, they look at this list of like awesomeness and they're like, so what's an IPython, right? Like the people in this room are maybe not as sensitive to if you really want to reach campus, not just the STEM disciplines, we really need to explain much more basic stuff, right? But I am not explaining stuff to those people right now, so I'm going to set that kind of person aside and jump right into some of the exciting technical tools. So Linux, it's relatively easy to configure with scripts. everything builds there. How many people can build their stuff somewhere besides Linux, but can't build it on Linux? Right. So especially if you have a uniform environment, right? So like if we're all using Ubuntu, for example, it gets even easier. And then, you know, documentation support is not great in the world, right? So you could sort of set this first baseline. It's like, well, right now it maybe is terrible. We could ratchet it up to where we're at least supporting and documenting a reference Linux distribution, right? Which is a approach taken by a lot of successful projects, right? Like Docker, for example, initially targeted Ubuntu. That was it. So you want to run Linux everywhere so that we all have this reference distribution. How do you do that, right? Even on Windows and Mac laptops or in the cloud, right? Running a virtual machine is hard like the IPython notebook is hard. It's hard until you actually just install it and start it, and then you say, oh, right? It's not really hard. So I'm not actually going to say much about that. If you haven't used a virtual machine before, I'll provide a link. You can check out ours, but just download VirtualBox and try it. It's like you just click buttons. It's very easy. I think for most people in this room, right? Not necessarily for everybody. So configuration management can also be very easy, right? You already know Shell and Python, package managers like apt, pip, conda, whatever else you use, right? So here's a simple strategy for configuration management, right? So here's something you would like type to set up your machine somehow. You can totally put that in a file, and then you can share that with people. That is a totally valid configuration management approach, and actually that's what we tried a whole bunch of stuff and we've fallen back to this because it's just easier to get people to understand it and contribute. We're also using the Debian Installer, which is awesome. It's by Joey Hess. He's one of my heroes. Everything you can click or type in an installation, basically you can script using the Debian Installer. And you can coordinate all this stuff using Packer. Packer is very simple. It makes VM images. It's only required when building the images, right? So it's a burden on me, but it's not a burden on my students, the researchers I'm supporting. Right? It coordinates basically everything I just talked about. And you write a JSON script, so there's no comments. That's kind of the only downside. I'm just going to very quickly go through some technology we've tried, but we decided not to use. So there's these fancy configuration things like Ansible. Ansible's awesome because it's named by Ursula K. Le Guin. You can configure any machine that just has Python and SSH. It's really easy to set up, easy for me. It's relatively simple, right? There are other tools you could use, but I'll just say, sort of go into Ansible really quick. Here's what Ansible looks like. It's not that hard to understand. Here's what the same shell script looks like that does the same stuff. I think probably how many people are confused by this? Right, so this, like, how many people instantly understand what this is doing? So a few, right? But this is, if you want to like randomly pick somebody in this room to work with you, if you start here, they're ready to go, right? So this is one of the reasons we've kind of abandoned some of these. I'm going to skip. I'm going to mention very quickly Vagrant. Downside of Vagrant, all users need Vagrant tooling, right? So we were really excited about Jiffy Lab. We tried using Vagrant with students in our classes. They could not, no one was able to successfully set it up on their own. Everybody took class time to set it up. It's basically a wrapper around VM systems. It also does configuration, but it needs to start with a Vagrant box. So you need to have something like Packer already or use a box somebody else built. It's cool, feels like hacking. Configuration's in Ruby. I don't know how you feel about that. But it's better than JSON. And then Docker is the final technology I'll mention. And basically it's this general idea that you just have this single kind of binary format that can map any application to a little Linux system running anywhere. Right? You know, couldn't we just do that with VMs? Yes, but that would be inefficient. Right? If you run on bare metal, it's more efficient. I should stop for questions in 5, or I should stop? Okay. Thank you. So Docker actually, if you have a Linux machine running on bare metal, right, that means it's not virtualized at all. Docker uses LXC, that's Linux containers, and other technology to run on the same kernel. So it has very little overhead. But unfortunately, if you're running Windows and OS X, you still need to run a Linux VM. So again, this is one of these things that's really cool, but it adds complexity, and we are not using it now. If you have performance needs, like useful example of Docker in an academic context was to do auto-grading efficiently. So you have like isolated environments, you want to run different students' code, and you want to have them all isolated in a virtual environment that they can configure. Docker can let you do that very efficiently. All right, so my more recent inspiration is this thing called OSGeo Live. It's a virtual machine. It's just configured with Shell, Python, and Perl scripts. Right, packages follow standard layouts. You have common resources like WSGI servers. Right, that's like a standard Python web server. They're clearly configured. And why is this exciting to me? Because a lot of people are using it. A lot of people are contributing to the installation scripts. Right. Why is this? It's because everybody who's writing like some geospatial package already has scripts to install on Linux. Right? That's all OSGeo demands of contributors. They also have very active outreach. So just very briefly what we did, we created a clever pun, which is very important to keep me motivated. It's actually from the chair of the statistics department. We're keeping it very simple for now. Right? We optimize for seamless installation and use, and I think we've achieved that. Students with Vagrant were like, why are we doing this? This sucks. And now they use it and they're like, wow, thanks so much for like making this very nice environment for us. So like virtualization can be awesome, it can be terrible. You need to be attentive to your users. We're really sticking to installation as only GUI. And it's like install VirtualBox, and then you, from VirtualBox, install this blob. Done. We target a single OS with a uniform UI, and we're reaching out to instructors now. Ideally, we're making building nice. We're trying to break it apart so that someone who knows what they're doing can, for example, just grab the requirements file and install the Python packages, right, if you don't want to mess with the full VM. But that's kind of a secondary concern. And we're using basically the tools that I was talking about. We're using the Debian Installer to set up the base Ubuntu machine, and then we just use clear conventions with package management and so forth. Packer's great. It does one thing. Most other DevOps tools kind of do a lot. It coordinates all those steps on the previous page, and it's only used at build time. You use it, and then you forget about it. This is what our runtime looks like. It's really stripped down. Everybody gets the same editor, same colors, same pixels, basically. It's very easy to give descriptions on how to open the shell. You click on the little black square with the $sign inside of it, right? As opposed to like having idiosyncratic instructions for every possible environment. And I'll skip through some of this. You can run it on Amazon or on VirtualBox. Packer makes it easy to build for just about anything. And simple things like there are these tweaks that you wouldn't do if you're just building a one-off VM, but having a little bit of institutional investment, we make it a solid color background so it's more efficient over a network. Right? We configure spaces for tabs and little things like that just to avoid hiccups. So this is ready to go. You can go to collaboratool.berkeley.edu. That's an old name we were using. Sorry if you think it's silly. There's simple instructions there on how to use VirtualBox or Amazon. And this is for UC Berkeley, right? So please keep that in mind. We welcome loose collaboration. I think the right thing to do would be to like fork it and like start building something for your instructional research needs and let us know how it goes. So I will pause there and say thank you. There's the URL. And then I actually had this idea. I can edit this slide as if people have questions or ideas. So I'll Are you? What?
Let's ask her.
Yeah, this is just here as like, I'm going to edit this as we go.
I'm not sure I'm going to answer that.
Oh, that's okay.
So the virtualized environment really works well for this uniformity in a teaching environment. How are you finding it works when people want to work with their data? Are they bringing it into that virtual environment? Or are you finding that they like that approach?
Yeah, so I actually work with, oh yeah, so the question was, how does this actually work in a research context, a collaborative research context? So I am personally using it for that with people who are really not familiar with scientific computing. It's a startup that works on helping people reduce their carbon footprint. And so I started making, it's like, oh, I'll just make some IPython notebooks and share them. They'll obviously know how to use those, right? And there's no. And so I made a little VM. Again, I started with Vagrant because I was like, oh, we're all developers. Vagrant's like how developers do this. And they were like, not getting it. So eventually I just gave them a VM to run a VirtualBox. It's got a database pre-configured that can pull down all of our stuff from the online backups, and very easy for them to run. Everything's just set up. And even there, they're still like barely hanging in there. So I mean, it depends who you're working with. But for my use case, it's been very useful to share like, okay, here's what I've done, and you can actually run it. You know, you can hit the most recent version of the data without my being there, because I kind of gave you this complete environment. And I work in that environment too when I'm working on that stuff. And really, like, VMs have gotten much better than they. I have used VMs in the past, and they're kind of slow, and it's very easy to. You know, I don't know how many cores you have, right? But you can like give 2 or 3 cores or 4 cores to your VM and enough memory, and it'll be very snappy. So.
When students learn skills in a VM rather than their own computer, do you ever find that they have trouble switching that into their daily workflow on their own computer?
So the question is, do students have trouble switching into their daily workflow after they learn skills on the VM? And if they were on their own, probably they would a little bit. But I mean, that's another piece of like taking into account the Berkeley context. There's like 2 meetings a week. Well, not during the summer, but where people can drop in and get help. There's consulting in the D Lab. There's help via Berkeley Research Computing, and if you're in statistics via the computing. So there's just people in place to kind of bridge those things. So like goal 1 is to just give people like a clear conceptual model of the core tools, right? And then they can figure out like what that looks like in their own idiosyncratic system.
So I have a question. So this reminds me, it's easy to do things like scientific clinics or Edge1.2, which are more global in scope, but still have the same pop-up focus.
Mm-hmm.
Describe your thoughts on why you didn't use or something like that.
Yeah, so the question is just why didn't we use something that already existed? Basically that boiled down to so we actually started with more of a standard approach, like just use like a PPA or something like that to give access to scientific computing stack. But we shifted. We just got demands from instructors like, I want this version of this library because it has this feature that I need that makes it much easier to teach or something like that. So it's just it provides us the ability to be responsive, right? And we're still building. I mean, if you go and look at what we actually implemented, it's trivial. It's incredibly trivial on top of Ubuntu. It's not like we're going and architecting our own distribution. It's just a thin layer of setting up an Ubuntu VM. Like avoiding the full Xubuntu stack, like just installing the core pieces we need to keep this size as small as possible, things like that. So the question was basically, has anyone used this outside of our immediate community? And the answer is no. I mean, that's one of the reason I brought up OSGeo is because it's a project that's organized kind of like this, and they seem to be doing very well. People seem very happy with that. No, so OSGeo is built on top of Xubuntu and just has scripts like Shell, Python, or Perl scripts. And there's contention and debate, but the VM is still currently built that way. And you can grab those scripts very easily and run them on whatever Ubuntu or Debian. So.
Okay, that was great. Let's give Davo another round of applause.